So we can use the technique of completing the square to derive a formula for the roots of the general quadratic equation ax squared plus bx plus c equals 0. So a and b are just coefficients, and c is a constant. So a, b, and c represent numbers. They're not a variable. They don't represent different numbers. They just represent some number. We just don't know what it is, so we're using a, b, and c. And by using the general form of the equation, if we can prove something true with the general form, then it's true for the specific form as well. And we do know what a, b, and c are. All right, so we're going to solve for x here using completing the square. So we have ax squared plus bx plus c equals 0. And I forgot to mention, this is in your notes, so you can take notes. All right, so step 1 is going to be to divide all terms by a. Anytime a is not 1, and we don't know what a is, so we don't know it's not, so therefore it's not 1. We want to divide by a, so I'm going to divide this by a, this by a, this by a, this by a. Everybody gets divided by a. The a's will cancel now, we just have x squared. So x squared plus the coefficient now on x is now b divided by a. So now b is b divided by a, plus c divided by a, and anything, 0 divided by anything is 0. All right, so now our second step is to isolate the constant term. So that means we're going to subtract c divided by a from both sides. So we have x squared plus b divided by ax. And I'm going to leave myself some space. Equals negative c divided by a, right? Because we subtracted c divided by a. Our third step is to make the left-hand side a perfect square. And we can do that by adding b divided by 2 squared to each side. But what's b? Well, b is the coefficient on x. So therefore, b is b divided by a. So b divided by 2 would be b divided by a divided by 2, and then we'll square that. So let's do the same thing to the other side, plus b divided by a divided by 2, all squared. Now that would be easier to simplify if we rewrote that a little bit. So remember that dividing by 2 is the same as multiplying by half. So let's just write this a little nicer. And you have x squared plus b divided by ax plus, let's write that as, we'll write it and then we'll square it. B divided by a times 1/2 all squared. That looks a lot nicer. Equals negative c divided by a plus b divided by a times 1/2 all squared. So we're just, step 4 is just we're going to simplify. All right, so now let's square that value. So we have x squared plus b divided by ax plus. All right, so that's just a product and a quotient. Remember, you can distribute a square to a product or quotient. So in the numerator, we're just going to have b squared. In the denominator, let's put the number first, because usually we put coefficients first. So 2 squared is going to be 4, and a squared is going to be, well, a squared. Equals, let's do the same thing on the other side, equals negative ca plus b squared divided by 4a squared. All right, so now we can factor on the left, and we can simplify on the right. All right, so remember the factoring is always going to be x, whatever the sign of b is, and then half of b. And you've got 2 of them, so you can write them as squared, because you have 2 binomials, and they're going to be the same since this is a perfect square. And how do we know it's a perfect square? Well, we added b divided by 2 squared to both sides, and that's what will make this a perfect square on the left-hand side. All right, so we'll factor. So that's going to be x plus, well, half of b is just going to be, I'm going to grab highlighter. Oh, I have a box. It's blocking my highlighter. There we go. All right, so half of b is just, oops. Oh, I put my pen down. All right, try that again. This value right here, which is the same as this value right here, that's right there is half of b. I'm going to get rid of the green scribble. Oops, not the yellow. The yellow can stay. Be that way. There we go. Get rid of green scribble. All right, so on the left we have x plus, and let's write that nice before we so let's simplify. Let's make b divided by a times 1/2 look nice. Let's write that as b divided by 2a. That looks a lot nicer. And all of that is squared. Equals, we can combine the terms on the right and left if we had a common denominator. So the denominator on the second term is 4a squared. The denominator on the first term already has an a, but it's missing a 4 and another a, right? So if we multiply the denominator by 4a, we have to multiply the numerator by 4a. All right, so that's going to give us, so we're going to have, and let's rewrite it. So instead of having negative 4ac plus b squared, let's put the b squared first. So we have b squared minus 4ac, and now we have one common denominator. We can just put that over 4a squared. Our next step is to take a square root of both sides. All right, so on this side, we have x plus b divided by 2a squared. And on the other side, so since we have a quotient, a fraction here, we can take the square root of the numerator and the square root of the denominator separately. I need just a tad more space. That's a little bit more space than I needed. We'll just go right to the top of the problem. There we go. All right. So square and square root cancel. Trying to fix that b. Yeah. Square and square root cancel. So this on the left-hand side is just going to be x plus b divided by 2a. On the right-hand side, can't do anything with b squared minus 4ac, but 4a squared is a perfect square, and the square root of that would be 2a. Our last step is to solve for x. Right, we want to isolate x. So all we have to do is subtract b divided by 2a from both sides. And that's going to give us x equals negative b divided by 2a plus or minus the square root of b squared minus 4ac all over 2a. And since we do have a common denominator here, but I'm starting to go downhill, aren't I? We can rewrite that as one fraction. So let's do that. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And I think I've seen that somewhere before. Where have I seen it? I can't remember. Let's turn the page, and maybe that will remind us. Or maybe we've seen it before. Oh yes, that's the quadratic formula. The roots of the quadratic equation ax squared plus bx plus c equals 0, where a is not 0, are x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And hey, that's what we got. Well, now you can't see it anymore because it's at the bottom of the screen there. But here, let's go. Let's do that. And hey, that's what we got using completing the square. So we used completing the square on both sides, or with our standard form of the equation, and we got the quadratic formula. I wonder if that's how they got the quadratic formula to begin with. Let's find out about that. So I'm going to end this podcast, and let's learn a little bit about where the quadratic formula came from, and then on the next podcast, we're going to use that quadratic formula to solve for some variables. All right? Thanks for watching, and bye for now.